Question 7. Find the coordinates of the point of inflection of the curves a, y equals to the x cubed minus 6x squared plus 9x plus 2. Okay, given the cubic function y equals to the x cubed plus 6x squared plus 9x plus 2, and first here you find the first derivative of the cubic function. Differentiate y with respect to the x. First derivative dy over dx here equals to the 3x squared minus 12x plus 9. Yeah. And then you find the inflection point using the second derivative, and the second derivative here equals to the 6x minus 12, and the inflection point of the cubic function here define or exists when the second derivative equal to the 0, and you let the second derivative equal to 0 and find the value of x. X here equals 2. Okay, and you find when x here equals 2 and substitute into the cubic function and find the value of y. Y here equals to the 4. Okay, x here equals 2 and y here equals to 4. Here is the coordinates of the point. Yeah, and tables of concavity. First row here you put the intervals of the function, second row the second derivative, and the third row here concavity of the function. Yeah, and the graph of the cubic function. So domain of the cubic function here defined for all the real numbers, negative to the positive infinity. Okay, and the value of x here equals 2. So graph here defined for all the real numbers. So you draw the number line. Start at the negative infinity from the left to the positive infinity. Yeah, and first interval from the left here, negative infinity to x equals 2. Okay. And the second intervals 2 to the positive infinity. Yeah, so you put the first interval here at the second column, negative infinity 2, and you write down the second intervals 2 to the positive infinity. Yeah, and then the second row, the sign of the second derivative. First interval negative infinity 2. Okay, and the nearest value from the left here between negative infinity and 2, you pick the nearest value. X here equals to the 1. Yeah, 1. So here the value of x equals to 1. Okay, and x equals to 1, and you substitute into the second derivative, and the value of second derivative here equals to the negative 16. Yeah, and the sign of the second derivative here negative. Yeah, and here you put the negative sign. Okay, yeah. So when the sign of the second derivative here negative, so the concavity of the function graph here concave downwards. Yeah, you put here CD. CD is concave downwards. Yeah, and second intervals 2 to the positive infinity. The nearest value after 2 here, you pick the value of 3. Yeah, and then the same x equals to 3, and here you substitute into the second derivative. Okay, you substitute into the second derivative, and the answer here equals to the 6, or the positive sign. Okay, and the sign of the second derivative here positive. Yeah, so you put the second row here positive sign, and the third row concavity of the function, so graph here concave upwards. Yeah, CU. Okay, and the second derivative change sign at the x equals 2. So from the left here, the sign of the second derivative negative, and after 2, this one the value of 2 at the center here. Okay, and then after 2, the sign of the second derivative here change to the positive sign. Yeah, or the concavity from the left concave down, and after 2, graph here concave upwards. Yeah, and conclusion, inflection point here exists at 2, 4. Yeah. Okay, and question 8. Question 8, find the coordinates of the point of inflection of the curves using the first derivative. Okay, so this one, the second method to find the inflection point. Okay, first the cubic function y equals to the x cubed minus 3x squared, and here you find the first derivative of the cubic function. Differentiate y with respect to the x. So first derivative here, dy over dx equals to the 3x squared minus 6x. Yeah. And then you find the second derivative of the cubic function, 6x minus 6, and when the second derivative here equal to 0, so the inflection point here exists. Yeah. Okay, and you let the second derivative here equal to 0, and you find the value of x. X here equals to 1, and and you find the coordinates of the point. X here equals to 1, and you substitute into the cubic function, and the y here equals to the negative 2. Yeah, and the coordinates of the xy here equals to the 1, negative 2. Okay, and you draw the table of the first derivative. Okay, first row here you put the value of x, and the second row here the first derivative. Yeah. So the value of x okay, so the value of x here equals to the 1. Okay, and the value of x here equals to 1, and this cubic function defined for all the real numbers here between negative to the positive infinity. Yeah, so first interval here from the left, negative infinity 1, and 1 to the positive infinity. So the first row here, you put the intervals of the cubic function, negative infinity 1, and the second column you put the second intervals 1 to the positive infinity. Okay, this third column you all cancel. Okay, and then second row here you find the first derivative. Yeah, okay, and the second row here you find the first derivative of the cubic function. So first derivative here equals to the 3x squared minus 6x. Yeah, and the first interval, the nearest value from the left of the function, the nearest value here you pick the value 0.9. Yeah, okay, 0.9, and you substitute into the first derivative. Okay, so you substitute into the first derivative, and the sign here equals to the positive. This one you check using a calculator. Equals to the negative sign. Okay, and then the first interval here, the first derivative equals to the negative sign. Yeah, and the second interval between 1 to positive infinity, you pick the nearest value 1.1. Yeah, and you substitute into the function, and the sign here equals to the negative. Okay, you check calculator, negative. Okay, okay, and the sign of the first derivative does not change at the x equals to 1. First interval between negative infinity 1, the sign of the first derivative here negative, and after 1 to the positive infinity, sign of the first derivative here equals to the negative, and then conclusion you here 1 negative 2 is a point of inflection. Yeah. Okay, if you draw the graph of the cubic function, so first interval here from the left of the function between negative infinity and x equals to 1. Okay, you check the sign of the first derivative. Here the sign here decrease, negative, negative, and negative. and the gradient of tension here decrease between negative infinity and 1. And after x equals to 1, the second intervals 1 to the positive infinity, you check the sign here, negative, so the gradient of tension here decrease to the positive infinity. So you put the sign here, negative, negative, and negative. Yeah. So the sign of the first derivative does not change at the x equals to 1, and the inflection point here exists at the x equals to the 1, negative 2.